Earth, often referred to as the blue planet, indeed seems to live up to its name when viewed from space over the Pacific side. And yet, it's only an illusion. Because if we consider our planet from the perspective of space that's accessible to life, it is predominantly black.
Nearly total habitable volume of the biosphere is in the great depths, where the heat from our star never descends. These vast liquid and dark stretches, populated by strange animals that you currently see in the image, have remained unknown to us for millennia. Most of what we knew about the depths of the sea then came from what was washed up on the shore and raised in our nets.
And in the 1830s, almost all scientists agreed that in the deep ocean, in the absence of light and therefore of plants, there was no longer any life beyond 500 meters deep. But barely a decade later, when one of the first transatlantic telegraph cables is brought up for repairs, it was found covered with coral and clam incrustations living attached to it 2,000 meters deep.
Against all odds, there are many forms of life down there, evolving in a world of darkness. And for over a century, we were forced to explore these great depths blindly. Because without being able to go there directly, all the study campaigns brought up life from the abyss haphazardly. A bit like if we were trying to understand the nature of those evolving on the surface of continents, from balloon mounts perched at night above a thick sea of clouds, while letting large butterfly nets drag below, hoping to bring something up.
But from the 50s, with the development of manned submersibles, then robots fixed to a cable, the exploration of the great depths really began. Almost all the forms of life that were discovered there below were then new to us, but also in a sense similar to all those known on solid ground. Because the animals we could observe evolving in the abyss also indirectly depended on the sun's energy and food that came from the surface denied to flow to them.
Until the most surprising and perhaps wonderful discoveries took place in 1977. When, somewhat by chance, scientists set off to explore the oceanic ridge located off the Galapagos Islands in their submersible, they did not fall by 2,630 meters deep on immense mineral structures resembling giant termite mounds.
Around these underwater chimneys, spitting at their top a burning fluid loaded with minerals, methane and hydrogen sulfide, we have discovered an extraordinary fauna which, far from the often desert monotony of the surrounding deep sea, rivals in terms of diversity with the humid tropical forests. Attached to these hydrothermal sources bloom oases of colourful and abundant life, to the point where we can find up to 50 kilos of living beings per square metre. And the most astonishing part of this story is that the life that flourishes here in the dark has nothing in common with all the other known forms on our planet.
Without knowing it, we had just discovered unprecedented forms of life that, in many respects, have something a bit extraterrestrial about them. Because the organisms that thrive here do not depend on the sun for survival in any way. Our star could very well go out at this moment, and it would continue to prosper, unimpeded in these deep and dark waters. While we always imagined that without a nutritious contribution from the surface, nothing could live on its own in total darkness, we have found on these sites vast colonies of bacteria feeding not on what falls to the bottom from the surface, but drawing their energy directly from toxic compounds, minerals, and heat emitted by these hydrothermal mounts. And this by means of a totally new process, chemosynthesis.
And in a way, we had just discovered a profusion of new life in a world where it was not supposed to exist. Living beings able to feed on things considered so indigestible that their very existence would have been rejected as absurd if someone had been imaginative enough to suggest it. To appreciate the magnitude of this discovery, we need to take a few seconds to shed light on this incredible process that is chemosynthesis.
Unlike photosynthetic organisms that use the sun's energy to transform carbon dioxide and water into sugar and oxygen, the chemosynthetic bacteria discovered here rely on chemical energy to oxidize the hydrogen sulfide spewed out by hydrothermal vents and thus produce sugar, oxygenated compounds which they feed on.
In other words, if photosynthetic organisms live by eating light, carbon dioxide, and water, chemosynthetic ones delight in methane, sulfur, or other minerals. As for all living beings who do not perform any of these two reactions, they must, in order to live, eat the species that do them or eat each other.
Thus, in this total darkness, by transforming toxic, inorganic compounds into nutrients, chemosynthetic bacteria are the first links in a large food chain on which a rich and varied macrofauna depends for survival, growth, and flourishing.
And in this joyful chaos, made possible by these microorganisms, you find bivalves, anemones, abyssal fish, crustaceans, octopuses, and thousands of shrimp hatchlings, all keeping a respectable distance from the chimney outlets, where the fluid, laden with toxic compounds that would make you regret being born, approaches 350 degrees. This temperature, sufficient to melt lead, drops rapidly as one moves away from the mouths of the vents to end a few meters away, at 2 or 3 degrees above freezing point.
Thus, it has been observed on the margins of these nightmare waters, sea worms nearly 3 meters long, moving in water that is 140 degrees hotter at their head than their tail. Today, we know of hundreds of these types of formations scattered across the globe, and their total number is estimated to be in the tens of thousands.
All these vents have been discovered between 700 and 5,000 meters deep, and mainly in areas of high tectonic activity along the axes of the oceanic ridges. We now know that these hydrothermal vents form when cold ocean water seeps into the crust through cracks. Cracks caused by magma chambers located a few kilometers beneath the ocean floor. As it approaches the covering magma, the water heats up, increases in pressure, and then rises, leaching the surrounding rocks in its path. At the exit point, upon encountering the surrounding cold water, the dissolved metallic elements will begin to precipitate, constructing impressive structures in their path. For while most of these metallic pillars do not exceed a dozen meters, some have been found that are an exceptional 100 meters high.
The extremely hot and acidic liquid that comes out of the vents removes some of the Earth's internal heat overflow to the point that it is estimated that 24 of these chimneys produce as much energy as one of our power plants.
Inevitably, these underwater geysers quickly come to extinguish. Ephemeral, they move and migrate because the exit points of the fluids are determined by the variations of seismic activities along the ridges. It is estimated that the average activity duration of one of these smokers is a few decades. Consequently, from one visit to another, submersibles often find that a once active site has gone extinct.
In fact, it was the discovery of these deep-sea smokers that solved one of the greatest mysteries of oceanography, namely why the oceans do not become saltier over time, knowing that the salt from the continents washed away by rain ends up there almost inevitably. In fact, it was realized that when infiltrating the oceanic crust, seawater is largely desalinated. Thus, it is estimated that these formations, acting somewhat like filters for giant aquariums, can cleanse a volume of water equivalent to that of all the oceans in just a few tens of millions of years.
While the majority of known hydrothermal vents spew black smoke, white ones have also been discovered, whose emissions are slightly cooler and of different compositions. In this video taken at 1,600 meters depth, one can see liquid carbon dioxide droplets escaping from the oceanic crust due to the significant pressure that exists here. And in this highly acidic environment, mussels are thriving, gently flowing over a microbial carpet, which is a meter thick in places.
And perhaps the most astounding thing is that we have also discovered other oases of life, nearly 3,200 meters deep, on strange formations called cold seeps. Here, in this astonishing environment, water emissions rich in hydrogen sulfide and hydrocarbons, emanating from the oceanic crust, occur at a temperature only 1/10 of a degree above the near freezing point at the bottom of the oceans. And chemosynthetic organisms adapted to these environments do not necessarily need high temperatures to thrive.
Thus, despite this icy environment, we can find several tens of kilograms of organic matter per square meter here. In the deep waters of the northern Gulf of Mexico, groupings of several thousand tube worms have been found, providing habitat for a myriad of other species, such as anemones, shrimp, copepods, snails, crabs, fish, and hens.
All as much as they are find abundant food here, thanks to the activity of chemosynthetic organisms. Some of these giant tube worms are so large that their age has been estimated at nearly 400 years. Lacking a mouth, anus, and intestine, they owe their survival to the symbiotic relationships maintained with their chemosynthetic bacterial flora, which indirectly provides them with the nutrients they need.
And once again, these creatures that can sometimes seem to come straight from another planet do indeed live on our own world. Sometimes, at these oases of life that can flourish in the icy waters, one can even come across mounds that remind us of ice, of snow. A snow that is nothing more than methane hydrate kept in solid form by the pressure of the column of water above us. Here, a cluster of mussels feasts on a type of chemosynthetic bacteria that is capable of ingesting and transforming the chemical elements of this hydrate into assimilable resources.
And just to add another layer of strangeness to the odd, imagine that it is common to come across brine lakes near these cold seepages. Yes, you heard right. As crazy as it sounds, there are lakes beneath the sea. These form from the accumulation in basins of extremely salty water, which is much denser than the surrounding ocean water.
It was in fact in one of these lakes that the very first multicellular life forms capable of living entirely without oxygen were discovered. The same planet, definitely another world.
And at a time when many governments and businesses are coveting the possible future exploitation of the deep sea, which around hydrothermal vents are teeming with riches in the form of billions of tons of accumulated minerals, one has to wonder if, after all, the real treasure buried in the abyss is not the great diversity of life that flourishes there itself and the huge reservoir of possibilities to discover.
Consider that today, nearly 50% of cancer treatments are derived from molecules originating from marine organisms. The venoms of many deep-sea mollusks are currently being studied to make painkillers 1,000 times more potent on a volume basis than morphine. As for the study of tubeworm hemoglobin, it could well someday allow the manufacture of artificial blood and universal honor. There are even species found on cold seeps that can feed on and break down oil. This is of great interest to soil decontamination specialists.
And it's truly mind-boggling to think that the discovery of these strange forms of life, which couldn't care less about the sun, also shook up and overtook everything we thought we knew about the adaptability of life on our planet, as well as scenarios for its possible emergence elsewhere in the universe. And this was at a time when we already had more detailed maps of the surface of Mars than of the seafloor.
Today, a number of theories hypothesize that these nightmare waters may have originally been the cradles of life on Earth. In fact, it is thought that the moons of Saturn and Jupiter, Enceladus and Europa, might well harbour hydrothermal vents beneath the thick layer of ice that covers them. From there to imagining that strange forms of life are teeming nearby, it's only a small step.
Especially since the creatures that led us to consider these scenarios as plausible were not found in space, but a few kilometers beneath the surface of our own planet, 3,000 meters beneath our flippers and boat hulls.
Facing so many still open questions, in front of everything that still waits to be discovered, hidden at the bottom of the seas, we are slowly surfacing, accompanied by the sound of a black smoker. Thank you.